Hello, today we are going to look at an interesting probability question and use Geogebra to analyze the question. Now, the question is as follows. A point P is randomly chosen inside a square of side 5 cm. A circle with center P and radius 1 cm is drawn. What is the probability that the circle touches or contains one of the vertices in the square of the square? Now, first we can construct the square of 5 cm. So we go to the polygon feature and then we are going to click 5 cm like so, and then we are going to input 4 vertices, so a square will be produced here. Next, we are going to produce a circle of radius 1 cm. To do that, we are going to go to the circle with center and radius. Click anywhere here and input 1 cm. So here we go. We have a circle with radius 1 cm. Now, we are going to create just one more circle for visualization purpose, right? Like so, and the radius is 1 cm. Now we are going to change the color of this circle to maybe red. Okay. We delete that. Okay. Now, then we are going to move this circle to fulfill the criteria of the question. Now, as you can see in this configuration, the sides of the circle, the circumference of the circle, is not touching the vertex of the square, but this is the corners where the circle touches the corners of the sides. Now, if we move the circle to the left, you can see that it does not touch the vertex of the circle still right until it hits this point. Then the point here, it is just tangent to the vertex of the square. Now in a similar fashion, if we move down, we get the similar conclusion. At this edge, then we have the circumference touching the vertex of the square. Now, clearly the solution involved, we can actually visualize the problem by checking several spots. For instance, this would be a reasonable answer. Now, if we play around with moving of this circle, we can see that right about here, this will touch the vertex of the square. Now, if we move down a little bit and move to the right a little bit, again, we create another point whereby the edge of the circle, the circumference, is touching the vertex. So how do we look at this problem? In fact, upon closer inspection, we realize that if we fix this circle right here and we look at the red circle, this one, and we move it over, we notice that as long as it is within this upper quadrant of the circle, it will fulfill the criteria perfectly, as you can see so. Hence, the region where the point must be in lies in this quadrant. So we need actually only 4 quadrants. This quadrant, this quadrant, this quadrant, and this quadrant. Now we can actually plot that in very quickly with Geogebra. Now, there we go. So this 4-quadrant area, as long as the point is selected within this quadrant, this quadrant, this quadrant, or this quadrant, then it is going to touch or contain one of the vertices of the square. So we can now look at the solution. So the solution would be probability is equals to pi times 1 squared. Why is the answer on top pi times 1 squared? Because that is the area of the circle. Because these 4 quadrants here make up the area of the circle. Now the denominator is going to be the square, which is the full points, the full sets of points in which the full area in which the point could lie. So that would be 5 squared. Now then, if we actually compute this answer, now the answer will be roughly 0.1257. So the probability that the circle will actually touches or contain one of the vertices of the square will be 0.1257, or about 12.6%. Now let's make this slightly larger. So here we go. This is the solution to this problem. I hope you like the video. Please subscribe and like the video. Thank you.